Hello students, welcome to today's lecture. In today's lecture we are going to discuss about the third point of information theory unit, that is the Shannon-Fano coding. Objective of today's lecture: discussion on Shannon-Fano coding, numerical on Shannon-Fano coding. So first we are going to discuss about the procedure and what is the Shannon-Fano coding, and after that we are going to solve few numerical based on Shannon-Fano coding. So let's begin. The first thing, what is the source coding? So if a message having different probabilities and they are assigned same number of binary digits, and the information carrying capability of binary PCM is not completely utilized, this is the actual information rate is less than the maximum achievable rate. But if all messages have same probability, then the maximum information rate is possible with the binary PCM coding. And the efficient source coding should satisfy the following requirement. First one is the code word generated by the encoder should be binary in the nature, and the source code should be unique in nature. So these two are the conditions for getting a perfect source encoder. Then entropy coding, or it is also called as a data compaction. In data compaction, it is also called as a lossless data compression. It is basically a source encoding technique that has two aspects. First one is it is efficient in terms of average number of bits per symbol, and second one is the original data can be reconstructed without loss of any information. Thus data compression basically removes the redundancy from the signal prior of any information. So that is a job of using a entropy coding. There are various techniques used in entropy coding, but our focus is mainly on this two. First one is the Shannon-Fano coding and second one is the Huffman coding. So in today's lecture we are going to discuss about the Shannon-Fano coding. Before that, we'll just take a recap, or we'll just take a review of what is the statement of a source coding theorem. So given a discrete memoryless source of entropy h and the average code word length n bar for any distortionless sources bounded as n bar is greater than equal to h. So this statement is nothing but the statement of a source coding theorem. According to this n bar should be always greater than equal to h, where n bar stands for the average number of bits per symbol and h stands for the entropy. And the formula for entropy we have already discussed in the previous lectures, that is entropy is given by summation of k is equals to 1 to m pk log to the base 2 into 1 by pk, where pk is defined as the probability of occurrence. N bar is the average number of bits per symbol. This n bar is given by a formula, that is summation of k is equals to 1 to l, where l is a length actually, into pk into nk, where pk is the probability and nk is the number of bits present for that particular probability value. Shannon-Fano coding. It is a method of constructing a prefix code based on the set of symbols and their probability estimated or measured. The technique was proposed by in Shannon's A Mathematical Theory of Communication in his 1948 article introducing the field of information theory. In the field of data compression, Shannon-Fano coding, named after Claude Shannon and the Robert Fano, is a technique for constructing a prefix code based on the set of symbols and their probabilities estimated or measured. Basic techniques in Shannon-Fano coding: the symbols are arranged in an order from most probable to the least probable and then divided into two sets whose total probability are the close as possible of being equal. All symbols then have the first digit of their code assigned, and the symbol in the first set receives 0 and the symbols in the second sets receive 1. As long as any set with more than one member remains, the same process is repeated on those sets to determine successive digit of their code. When a set has been reduced to one symbol, this means the symbol's code is completed and will not form a prefix of any other symbol's code. Procedures to find out Shannon-Fano code. So for finding Shannon code message with their probabilities are given. Procedure to obtain Shannon-Fano code. The first step is list the source symbols or the message in order of decreasing probability. So once you have arranged them in the decreasing probability, we go for a second step. In second step, the partition the set of symbols into two sets that are as close as being equal as possible. Then assign 0 to each message in the upper set and 1 to each message in the lower set. Continue this process until time partition the set with a nearly equal probabilities as possible until further partition is not possible. So we have to repeat this procedure until there is no further partition is possible. So once you are done with this, we go for third step. So in third step, the third step is to find out the entropy and the average number of bits per symbol. So once the complete table is with us, we go for finding the entropy. So entropy is given by the formula h of k is equals to summation of k is equals to 1 to m pk log to the base 2 divided into 1 by pk, where pk is the probability of the given messages. Then second one is the average number of bits per symbol, which is given by n bar, is nothing but summation of k is equals to 1 to l pk into nk. So pk is the probability of the given messages and nk is the number of bits present for that particular or that respective probabilities, where nk is the number of bits presented for the kth probability. So once you are done with finding the value of entropy and average number of bits, our last task is to find out the code efficiency. So for finding code efficiency, the formula n is given by h by n bar, and the code efficiency is always measured in terms of percentage. Therefore, wherever we find the value of code efficiency, either multiply it by 100 or write down multiply by 100 and then write down percentage. Now let's begin with our first example. Apply Shannon-Fano coding procedure for the following message. Also determine its efficiency. So here they have given us a message in symbol and we have to find out its efficiency. So this is a given message. So x is your message and p is the probability. So here we are having how many sets of message set? 1, 2, 3, 4, 5, 6, 7, and the probabilities are: the x1 is having a probability of 0.4, x2 is having probability of 0.2, x3 is having 0.2, x4 is having probability of 0.08, x5 is having probability 0.08, x is having probability 0.08, and x7 is given as a probability of 0.4. So we are having a 7 set of messages with their respective probabilities, and from that we have to first we have to build a Shannon-Fano code and then we have to find out its efficiency. So let's begin. So our first step is the list the source symbols or the messages in order of decreasing probabilities. So just focus over here and we have to arrange them in a decreasing probabilities. So as they have already given in the decreasing order, so we just directly copy the value as it is, because the values are already in the decreasing fashion. So no need to make any changes. So once the messages are assigned in a decreasing probability, we go for second step. So in second step, we have to draw the Shannon coding table. So this type of table you have to draw. So the first is the message I of k. So this is a message which is given to us. Second column indicates the probability of that particular message, and next we have to write down the values or the steps for coding. So here the steps may vary based on the given sum. For this particular sum we are having a 4 step. In some cases the step may be 5, 6 or 3. And then the next column indicates the code which we are going to measure or which we are going to observe from the table, and finally the number of bits per message that is given by nk. So your table goes like this, and now we are start with the filling. Now listen carefully how we are going to fill this. So first 2 column indicates the value of a message or the message and its respective probabilities. So from the given message n symbol we just copy the values. So first message is x1 with a probability of 0.4, second one is a x2 with a probability of 0.2, x3 is equals to with a probability of 0.12, x4 is with a probability of 0.08, x5 is with a probability of 0.08, x6 is again with the probability of 0.08, and x7 is with the probability of 0.07. As the values are already in decreasing fashion, we have not changed any sequence, so we just note down the value. We have to note down the value as it is. So once you are done with note down this value, we go for second step. So according to second step, we have to take addition of all these values. So we are taking addition, that is a 0.4 plus 0.2, 0.12 plus 0.08 plus 0.08 plus 0.08 plus 0.04, and we have to take the medium value, or we have to divide this particular probabilities into 2 sections. So therefore this complete addition is divided by 2, comes out to be 0.5. So for partition the value is equals to 0.5. So we have to divide this section into 2 portions such that the portion is equivalent to 0.5. So how we are going to do that? So for that we have considering the first portion as 0.4. This is your first portion, and second portion is the next portion. So the addition of first portion comes out to be 0.4, and the addition of all these values comes out to be 0.6. So they are somewhat equals to 0.5. Okay, and once you are done with the partition, then we have to assign a value. So this principle or this technique is uniform. The upper portion is always assigned with a 0, and the values or the lower portions is always assigned with a 1. Now addition of this one is, this complete is your first portion, and the second one is your lower portion. So all the lower values are assigned with 1. So I have assigned all values with 1. So this comes out to be your first step. So in first step, we have divided the given probabilities into two sections. Upper one is 0.4, lower one is a 0.6. Upper one is assigned with a bit 0, and lower all values are assigned with 1. So in this way we go for a first step. So once the first step is over, we go for second step. Now here one thing is important. You have to split the bits until the section or that bit gets separate out. So here I am having only 0.4, so 0.4 value is 0 only. So further partition of 0.4 is not possible. Okay, so we focus on the lower section. So for lower section, just repeat the same step. So this is your lower section. Now our focus is on this lower section only. So first thing, you have to take addition of all this value and find out the median value. So here 0.2 plus 0.12 plus 0.08 plus 0.08 plus 0.08 plus 0.04 divided by 2. So divided by 2 comes out to be 0.3. So what we have to do, we have to divide this section into two partitions or two portions such that their addition is somewhat equals to 0.3. So how we are going to do that? So for that I am considering the first two values. So the first two value addition comes out to be 0.32. So this will form my one section, and the addition of last sections comes out to be 0.28. So this considered as my second section. So the upper section I have intentionally given with the green color, and then my lower section. So once you are done with the partition, then the second task is for assigning the bit. Now the upper section is always assigned with a 0, so therefore it is assigned with a 0. This one is also assigned with a 0, and the lower part are assigned with a 1. So this is all about your second step. So once you are done with the second step, now see, focus over here. Here we have not completely separate out the bits. So here we are having a combination of the bits. So we have to again split it into two portions. Now this part is left actually. So how we are going to separate out? So this is your first section, and this one is your second section. Now here we are just splitting these two values. Okay, so directly split it over here, because addition is 0.32 divided by 2 is somewhat equals to 0.16. So this point, we don't have any choice, so we just directly split it into two parts. So that's what I have done over here. We have split it into two parts, and for the rest part, now upper part is again assigned with a 0, and the lower part is assigned with a 1. So with this we have completely separate out the bit. So here the further partition is not possible. So this upper portion is done. Now we focus on the lower portion. Now the addition of the lower portion. So in lower portions we are having 0.08, 0.08 plus 0.08 and 0.04. So we have taken the addition and then divided by 2. It comes out to be 0.14. And again we have to split this section into two portions such that the addition is equivalent or somewhat equals to 0.14. So for that I split it into like this, first two together and last two together. Why I am doing so? Because the addition of first two bits is equals to 0.16 and the last two bits is equals to 0.12. So they are somewhat equals to 0.14. So once the splitting is done, then the second task is assigning the bit. Now this upper portion is assigned with a 0 and the lower portion is assigned with a 1. Okay. So once you are done with this portion, then our last part is separating out these two bits and these two bits. So for separating out these two bits, what we are doing, we don't have any choice. If only two bits are left, so we just separate it directly. So upper one is 0, lower one is 1, means upper partition and the lower partition. So upper one is assigned with a 0, lower one is assigned with a 1. Then again for this two, we just separate out them. One portion and the another portion, or upper portion or the lower portion. Upper portion is assigned with a 0 and the lower portion is assigned with 1. So in this way we do the partition. So once the partition is done, our next task is to find out the code. So how we are going to find out the code? So for that, our first message is x1. So initially I have drawn this line. So for first message x1, my code is given as a 0. For second message, so the second message is flowing from 1 0 0, so the code comes out to be 1 0 0. For third message, my code is 1 0 1. For fourth message, my code is 1 1 0 0. For fifth message, the code comes out to be 1 1 0 1. For sixth message, the code comes out to be 1 1 1 0. And then for the last, the code comes out to be 1 1 1 1. So in this way I find out the codes. So once the code is with you, our next task is to find out the number of bits per message. Means number of bits are used for transferring the message x1 with the probability of a 0.4. So for first, how many bits are there? So the bits are 1. For second one, how many bits are there? 1 2 3. Next the bits are 3. For next again the bits are 1 2 3 4. Then 4 4 4. Now one thing you observe from this particular table, your message 1 x1 is having a probability of 0.4 and the number of bits per message comes out to be 1, and for the last code the probability is 0.04 and the number of bits comes out to be 4. So what it indicates, now with decrease in the value of a probability, or the message which is having a less probability carries more number of messages, or more number of bits per messages are present in that particular case. So in this way we draw the Shannon-Fano table. Then we move to the second step, or the third step. So once the values are with us, we go for finding the entropy and the average number of bits per symbol. If entropy is given by the formula summation of k is equals to 1 to m pk log to the base to 1 by pk. The probability values are already given to us. We just have to put all those values. That is a h. First probability is 0.4. Second one is a 0.2, 0.12, 0.08 and 0.04. So we just have to put all those values and then we find out the entropy. Entropy comes out to be 2.42 bits per message. So once the probability is found out, we go for a second step, that is for finding the average number of bits per symbol. So it is given by probability pk into nk, and for each value of probability we have find out the respective value of number of bits. So we just have to put all those values. So for 0.4 the number of bits are 1, for 0.2 the number of bits are 3, for 0.12 the number of bits are 3. Here one thing is also important, as 0.08 is present for 3 times, so we have not taking the addition or multiplication for 3 times. So just multiply the value by 3, so it will give you the probability, actually the combined probability. And then finally 0.04 with the number of bits 4. So this will give you average number of bits per symbol. So once the value of entropy and the value of average number of bits are with us, our last and the fourth step is to find out the efficiency. So the code efficiency is given by, it is a division of h by n bar. Put on the value of h and n bar. So we are putting, and the efficiency comes out to be 97.5%. So in this way we find out the efficiency using a Shannon-Fano code. Now let's take one more example. This is a second example. Apply Shannon-Fano coding procedure for the following message in symbol, also determine its efficiency. So here they have given as a message in symbol message x1, x2, x3, x4, x5, x6, x7, and the respective probabilities are given to you. Now here I request you just pause your video for a while, try to solve this sum by yourself, and then resume the video, so that the doubts or if you are having any issue regarding the solving gets clear. Okay, so let's begin. So what is the first step? So the first step is list the source symbol or the message in the decreasing probability. Now as these probabilities are not in a decreasing fashion, we have to arrange them in a decreasing. So after after doing the decreasing process, my probability or the values I have changed. So the x1 is having probability of 1 by 4 and the x6 you have, so this thing is very important. If you are changing the sequence of probability, you have to change the sequence of messages. Okay, so the x6 is having a probability of 1 by 4, x4 is having a probability of 1 by 8, x8 is having probability of 1 by 8, x3 then 1 by 16, x4 1 by 16, x5 1 by 16 and x7 1 by 16. So you have to arrange this in a decreasing order. Then the second table, so in second table I have intentionally hide all those things. So this is for your thinking process, you just think over it. Okay, so again you just pause your videos, after one step is over you pause your video, try to complete it by or try to solve it by yourself and then resume your video and check whether you are getting the same answers or not. Okay, so first step, what is going to be a first step? The first step is we have to arrange the messages and the probabilities. So this is how we have arranged. Hope you all are getting the same sequence actually. So you have arranged it in the same fashion. So x1, x6, this thing is important. Okay, you have to arrange them in the probabilities, and for the same probabilities you have to write down the messages. So this all are my messages. So once this step is over, what is going to be my second step? So in second step I have to take the average. I have to find out the, not actually average, I have to find out the mean value. Okay, so for that, this my x comes out to be addition of all these terms divided by 2, and which comes out to be 1 by 2. So for getting 1 by 2 I have to do partition. So how we are going to do partition? So just take a while and think. So how you are going to partition? So for doing partition, hope you have done partition the same way. The upper 2 is your first section and this last 5 are your second section, because the upper 2 are having addition of 1 by 2 and same is the addition of the last 2. So once you are done with this step, then second is we have to assign upper portion with a value of 0 and the lower portions are assigned with a value of 1. So once you are done with this, what is going to be your second step? Second step is you have to separate out the upper section. So for separating out upper section, how you are going to separate it out? Directly separate it out. Upper one is 0 and lower one is a 1, and then you have to find out the median value for all these 5 values. So your median value in this case is 1 by 8 plus 1 by 8 plus 1 by 16, 1 by 16, 1 by 16, and it comes out to be 1 by 4. So how you are going to separate it out? Just think. So after separating out, I think you have separated out in the same fashion. The upper one is directly 0 into 1, that's it. And for the lower, 1 by 8 plus 1 by 8 comes out to be 1 by 4. So this is your first section, this one, this 2, and the lower section is having a 1 by 16 for the 4th time. So the upper portion is assigned with a 0 bit and all lower portions are assigned with a 1 bit. Then next step, what you are going to do, again you go for the separating out. So the 0 1 separate out, so no further values are there, but for the 0 0, as this is a combination, you have to separate it out, and in this case by default the upper one is 0 and lower one is 1, and then we focus on the addition of the lower portion. So for lower portion, this is 1 by 16 plus 1 by 16, 1 by 16 plus 1 by 16 comes out to be 1 by 8. Now how we are going to separate it out? Okay, so for separating out, we separate it out in the first 2 and the next 2 in this fashion. Hope you have all have done it in the same fashion. So this one is your 0. We know as these two are the combination, by default the next value is going to be 0 and 1, and then as this 4 ones are separated into 2 sections, the upper portion is assigned with a 0 and the lower portions are assigned with a 1. And once you separate out this portion, our first task is to separate out these 2 bits. So for that, directly this upper one is assigned with a 0, lower one is assigned with a 1, upper one is assigned with a 0 and the lower one is assigned with a 1. So in this way we draw the table, and once the table is with us, our next task is to find out the code. And for finding the values of code, how we are going to find out the code? That is, my x1 is equals to 0 0, x6 is equals to 0 1, x2 is equals to 1 0 0, and so on. So this is going to be my code. Now one thing is very important over here, that is for message x1 with a probability of 1 by 4, the code is 0 0. Then for message x6, you have to follow the sequence of a messages actually. So for message x6, the code comes out to be 0.1. For message x7, the code comes out to be 4 times 1, and again the same logic is applied over here. The message with the maximum probability is having minimum code word or minimum number of bits present in a code word, and the message with the minimum probability is having maximum number of bit present in a code word. So then number of bits per message, we have to find it out. So how you are going to find it out? It is 2 2 3 3 3 4 4 4. So that was it. So once the table is with us, our next task is to find out the entropy, n bar, and then the efficiency. So find entropy and the average number of bits per symbol. The formula for entropy is same, that is the summation of k is equals to 1 to m pk log to the base to 1 by pk. The probability values are given to us. I have just put on all those values of our probabilities. Okay, now here p is 1 by 4 actually, therefore it is 1 by 4, and log to the base to 1 by 1 divided by 1 by 4, your 4 value comes into numerator, therefore here it is 4. So I just write down all those value and then find out the log. Now how we are finding log to the base 2? By taking log of x divided by log of 2. So this comes out to be the probabilities. Now try to solve all this thing by yourself. So I hope you all are getting the same answer, that is a 2.75 bits per second, bits per message. Then average number of bits per symbol is given by the formula summation is equals to k from 1 to l pk into nk. Putting the values, that is the first message is having a probability of 1 by 4 with a number of bits 2. Second one is having probability 1 by 4 with a number of bits 2, and likewise, and then the answer comes out to be 2.75 bits per message. So once the value of entropy and the average number of bits per symbol is with us, we put these two values in the code efficiency formula, that is the efficiency n is equals to h by n bar, and the efficiency in this case comes out to be 100%. Thank you for listening to my video.